My name is Matthew Gardiner. I'm calling from Linz in Austria. Hope everything's great in Tokyo. Really wish I could have been there. So my talk today is an extension of my research into the aesthetics of folding and technology. And today the topic I'm discussing is on scale, dimensionality and matter. My name is Matthew Gardiner and I represent the Ars Electronica Future Lab. I work there as an artist and a researcher, and I'm currently a PhD candidate at the University of Newcastle in Australia. So, the nature of folding. One of the main questions I've been asking myself in my research is, what is a fold? And so I've been looking at a wide range of research, looking at mathematical research, been looking at science research, looking at artistic research, and also I've been looking at philosophical works. In particular, Deleuze's research or work on the fold brings out quite a number of things here, which I've kind of started to bring these together for myself in a kind of sense that a fold always embodies the duality of things. It always embodies this kind of, as you see here, these kind of opposites, but they tend not to be so opposite. They tend to be complementary pairs. And so what we find is that science and art are two kind of things that sit side by side, you know, on one above the fold and one below the fold. The relationship between code and matter. So in the way that genetic code becomes the organic matter of life that gets reconstructed. The nature of the interior and the exterior in terms of the masculinity of the peak of a mountain and the femininity of the valley of the feminine. So all of these concepts start to become evident in the work, in all elements of folding. And so the things I'm really interested in are these kind of, I think from these first few terms is the science and code and the matter and the art. And so these ideas are very common and very predominant throughout the work that I'm about to show you. In 2012, I published a book called Designer Origami, and in this book I started to explore the notion of scale in the introduction of the book. What I started to realize was that scales existed at that folds existed at all scales of nature. So from the nanoscale to what I call the origami scale, to the interior scale and exterior scale. So in between what's inside the house and what's outside the house, like exterior scale is like the size of architecture, so in buildings, and all the way up into space. And so we know these works, a lot of these works from our own research, and this would be not new information to most of you. Nobuo Miyamoto has made a much better comparison using metric measurements, and this is where these three projects that I'm showing you today, they all have, these three scales that I'm talking about today all work over a range of the scales that are talked about. So the first piece I'm going to show you is based on, inspired from DNA and folding and sequences. The second work I'm going to show you is more at an origami scale and relates to kind of bands or structures that are origami related, derived, and up to my recent works on interiors, so which could also be worked as exteriors as well, but they're two projects that I'd like to show you through how I'm working with them at the moment. One of the ideas that I kind of started to realize in terms of the dimensionality of folding is that folds, in a way, Deleuze points out that the fold is the smallest unit, so this sort of one-dimensional crease through matter. And so while I was doing my own work, I was studying a pentagonal tiling pattern by Albrecht Dürer, and you can see it here, and you can see the individual tile that I was working with. I was interested in looking at how origami tessellations, or how like the lines that make up the crease patterns, how they could be interpreted as folds, which they are folds, but once they're flattened out, to think about them. And I realized that at the very peak in the fold, at any angle, even in a drawn line, wherever there is an angle, we can start to consider it a fold, whether it's a fold of 2 dimensions, 3 dimensions, or 4 dimensions. If we begin with the first dimension, this 1D, it's just a line. We would know it as a crease in space. As soon as we bend that crease, as soon as we kind of make a fold in that one-dimensional line, that's when the object enters the second dimension. And so, again, the same process occurs to enter a third dimension. So moving at any angle away from that plane, the two-dimensional plane, we then create a three-dimensional shape. The expression now that we're hearing in 3D printing is for 4D printing is the expansion and contraction. So it's this opening and closing, expansion and contraction that we see in 3D, in the use of 3D printing. So essentially what they're doing in 4D printing is taking an object, folding it up, trying to cram it into a smaller area as possible, printing it out and unfolding it again, giving a larger object. So the last kind of conceptual idea I'm going to present to you, which many of you would know this. You'd know this intuitively from the way you work and from all of the different research that you do yourselves. So essentially, material is the relationship between folding and matter is that the way I see it is that the way that is that the folds create the shape. So the folds essentially form an essential part of the structure of any natural or any space-like object. So the ways in which I see that we can code for matter or like work with code is that using the origami example is that we know the example of working by hand, and so that's where traditional origami, symmetrical origami, works that are use pure land folds or that use use references that are not unusual, division of angles, all of those kinds of very traditional style, but still very much based on the geometry of the square and other set size sheets of paper. That's kind of what we can call by hand. In the second case, we have by chance. And so, well, chance or the application of force in a seemingly random way. There's been a lot of like in early papers by Miura show, the natural patterns like the Miura Ori and the water bomb, or the ananas pattern coming out purely through buckling and bifurcation. So these natural patterns are coming out. But now we're seeing, due to computation, is that we're seeing code as a primary way in which new crease patterns and new ideas are being developed in folding. So I see this as a main kind of aesthetic shift that's taken place. You can see it in the complexity of origami models. You can see it in the complexity of architectural design or in fashion design that takes advantage of and uses new tools and new ways for taking a simple origami pattern, either from hand inspired or chance or buckling patterns, and then applying code or algorithms to kind of either deform them, reapply them, or in the work that I'm doing, map them across new surfaces. So this first piece is called Fold Machine, and it's related to the DNA folding of coils. So Deleuze in his work talks about the coils and the soul, and so whenever I've read that, I've often very much connected to the idea of DNA folding, and so this kind of coiling up of nature that occurs. And so the way in which I approach this piece, so it's a conceptual piece for a machine which is fed strips of paper, and as those strips of paper go through the machine applies a genetic code to it. So this genetic code is based up on a set of folding sequences that are of complementary pairs, being A, T, C, and G, the same as the adenine, thymine, cytosine, guanine. These DNA kind of coding units can then be combined in sequences. And so this is a kind of a visualization of what that could look like in a physical sense. And I've been very interested in, for this piece, as I said, it's a conceptual piece. It's a sketch for an idea that connects these concepts. And I was very interested in the kind of the random falling and the kind of the natural patterns that would start to emerge, and the kind of the coiling that would occur, and the kind of complexities that you would start to see and start to imagine. So this is taking a very literal example of the so-called DNA origami that we know from scientific research, and applying the DNA origami concept very literally in an artwork. This body of work, and it is a body of work because it's based over a number, it's the first work that was made in this theme was from 2011, and my current works are all these kind of folded sculptures that are animated through light. My earlier aerobotic works were lit sculptural forms that opened and closed, and so it was just the folds themselves that are in motion. What I started to realize is that one of the beauties of my works, or one of the aesthetic qualities, was seeing the shift in shadows and seeing the movement, the difference between light and dark, the interplay between the geometric planes as they intersect. And so I realized I could shift the perceived geometry of the form by changing the light surface. And so you'll notice here's this essentially the way in which I'm working and making these sculptures. So this is a two-piece water bomb unit. This is running in Blender. I'm showing you here that what I have is a simplified version of the geometry. And the important part is that for the process that I'm working with grasshopper and rhino, is that all of the vertices are on whole numbers. So I'm pointing out as I turn the object that everything sits on the main grid lines. Now I'm just about to paste, I've just pasted in a bit of code that gives me all of those vertices. I do a little bit of text editing. So now I've got all the coordinates for that folded pattern, and I have to do a little bit of sequencing, a bit of calculating which point should go to which point to make up the edges and to create the faces. But once that's calculated, I then go to Grasshopper, I plug in that as a sequence, and that gives me the ability to construct this object. So I've got you see here, I've got the surface, I've got a set of just curves on a 2D plane. They then get combined to make a lofted to make a surface. And so then using that surface, I'm mapping, getting some grid points across that surface, and they're at set different intervals. Those grid points are then fed into another component, and that component is a 3D pattern mapping. So it's a paneling tool, and so I feed the coordinates that I collected from my folded geometry earlier, and I feed that into this component, and then that component generates this crease pattern. So this crease pattern, or this kind of folded pattern, this folded geometry, is, as I found, is I can unfold them using in freeform origami by Tomohiro Tachi. I can unpack those folds, and I can actually fold them up. So not only is it possible to create them in a virtual sense, but that's a refolded, a slightly higher resolution object. And so the intention for these works is to make them at a very, very large scale, or at an interior scale, at least, so where the size of the works is about between 3 meters and 6 meters on any given side. So here is a visualization of a felt version, some kind of soft felt folded wall. And what I've found very interesting about these sculptural surfaces is that the way the light falls on them, and this is without even animating any light, is that the way the light falls upon these works is there's a kind of a flatness and a denseness that emerges. You start to see where there's a density in the number of folds, it appears as though there's a kind of a shift in the planarity of the surface. It doesn't look like this is sitting across a flat surface anymore. It looks like it's very much a kind of wavy kind of textural surface. And I find this a very, very, very interesting factor. And this is again a visualization of the same piece that I showed you folded in my hand. And this is a kind of visualization of what they would look like tumbling, you know, as if they were water moving. So the next piece I'm going to talk to you about is called the Queen of Diamonds. So these are bracelet designs based on folded geometries. I've used a similar process. This time, instead of taking a flat surface, I took a toroidal surface, and I began working with like lots of like a high density of the folded surface. And I did a range of experiments to kind of try and find a kind of an aesthetic that fitted the structure. So this is the previous ones were water bomb bases, water bomb patterns, and this is a Mura ori, and that's kind of being twisted by one twist as it goes around the surface of the toroid. So these can be produced also as like flat geometries, though the idea is that this pipe-like geometry can be used and kind of printed and use a very minimal amount of material but still remain quite strong. The points that I eventually got to, however, were much more minimal. They seem to highlight the qualities of the folded patterns much more than the earlier pieces, and these are the kind of the final ideas that I began to work with and actually had fabricated. So on the left you see the visualization, and on the right you see the actual objects themselves as they were produced. Fallen Future is another conceptual work. This idea of this, the fallen future is a kind of sculpture that has fallen through time and space. So it's fallen out of the future back to meet us, and the idea is that we're kind of investigating what this object is, where it comes from, what kind of properties it has, what kind of, you know, how was it made. It has these kind of ingrained or like fabricated surfaces that are kind of coarse, that are somewhere between organic and electronic. We can see the embedded crease patterns. We can see that at some point they were kinetic, that they had some structure to expand and contract. They're definitely a hybrid between what is kind of a code and organic matter in a structure. And they also have like very new properties, like that we were able to discover, like exposure to light caused them to become brighter or darker. They have a lot of very new technology, a lot of technologies that we wanted to discover. But at the same time, they were vulnerable due to their organic nature. They were vulnerable to exposure to the elements. As you can see, they've kind of decayed and they've become old. And so it's ideas like this that let me start thinking about what would the artworks that I make now, what would they look like in 1,000 years' time? What would their kind of aesthetic, or what would their aesthetic value be? But also, in a way, trying to imagine what kind of future ideas are embedded in these sculptural forms that we could bring back into our practices today as ways to look forward. So I'd like to thank you very much. Hopefully I'm available online on Skype now. Apparently it's 4 a.m. in the morning, so by the time you hear this, it's at 4 a.m. for me, so if I'm up, hi, ready to answer any questions you have. Okay, and so thanks very much. Bye.